Hello, dear students. I'm Dr. V. Sadhana, Assistant Professor of Physics, St. Joseph's College of Arts and Science, Autonomous, Cuddalore. Today, we are going to discuss about second quantization of the Klein-Gordon field. Okay, what if matter is just music made visible, the universe humming through invisible fields? Today, we'll see how quantum fields describe the creation and annihilation of particles. The Klein-Gordon field is a simplest example, a scalar field describing spin zero particles like pions. Let us understand how the mathematical process of second quantization transforms classical wave equations into a framework that allows particles to be created and annihilated. We know classical and first quantized quantum mechanics deal with fixed number of particles, but nature isn't so rigid. High energy experiments show particles can appear and vanish. Like beta decay, a neutron transforms into a proton plus electron plus antineutrino. And pair production, a high energy photon becomes an electron positron pair. So these phenomena breaks the constant number assumption. So we have to enter into a new framework, that quantum field theory, where the fields are fundamental and particles are just excitations of those fields. So think of a lake, a wave's particles rise and fall, but the lake remains. So likewise, the particle rise and fall, the field remains. See, the Klein-Gordon equation is the relativistic wave equation for spin zero particles, which can be written as the Euler-Lagrange equation for x plus m squared phi is equal to 0, which can be derived from the Lagrangian density L is equal to half of dou phi psi, dou mu phi of dou mu phi minus m square phi square. So it respects the Lorentz invariance and predicts both positive and negative energy solutions. If time-space could vibrate like a drum, the Klein-Gordon field would describe its simplest note. So the Higgs field follows a modified Klein-Gordon form. It is a scalar field with self-interaction. Using the Euler-Lagrange formalism, the canonical momentum phi of x equal to dou L by dou naught phi is equal to phi dot, and Hamiltonian density H is equal to half of pi square minus del phi square plus n square phi square. This looks like the energy density of infinitely many harmonic oscillators, one at every point in space. So imagine each point in space has a tiny spring that can vibrate collectively. These oscillations form the field. Now comes to the lead, second quantization. In first quantization, we made position and momentum operators. In second quantization, we make the field itself an operator. That is, phi of x, pi of y is equal to I h cross del square x minus y. This turns a field into a quantum object that can create or destroy excitations. We no longer track where particles are. We track where the universe decides to vibrate. Hence, the Klein-Gordon equation solutions are plane waves, e power minus I omega kt minus kx. So we can expand the field operator as phi of x comma t equal to integral d cube k divided by 2 pi cube 1 by root of 2 omega k into a k e power I omega t minus kx plus a dagger e power minus omega kt minus kx. Here comes ak and ak dagger. Each k mode behaves like an independent quantum oscillator. So each mode is like a single tone in an orchestra. So the field is the full symphony. In the last slide, we had different notations AK and AK dagger. That is nothing but ladder operators which can obey AK commutation of AK comma AK dagger is equal to del cube K minus K dash. So these operators AK dagger is said to be creation operator and AK is said to be annihilation operator. So creation operator creates a particle and annihilation removes a particle. Think of a particle vending machine. So A dagger adds a particle and A takes one out. So in quantum optics, A dagger corresponds to emission of a photon and AK corresponds to absorption of a photon. Substituting the field expansion into the Hamiltonian, we have Hamiltonian H is equal to integral d cube k omega k of ak dagger ak plus half. Ak dagger ak is equal to nk. This is a counts number of particles in mode k. Half omega k, 0 point energy. The field vibrates even in vacuum. So this residual energy gives rise to the Casimir effect, measurable attraction between metal plates due to vacuum fluctuations. So even nothing isn't quite. The vacuum buzzes with quantum noise. In quantum field theory, particles are emergent. Each field mode behaves as an oscillator. The excitations are the particles we detect. So it may be electromagnetic field, Klein Garden field, and phonons. So waves on like a waves in water ripples are visible, that is particles, but water, the field, is the true substance. The vacant state is a ground state. AK of 0 is equal to 0. A one particle state, 1K is equal to A dagger of a 0 kit. So multiple particle states follow Bose-Einstein statistics. Get nk is equal to n factorial ak dagger n kit 0. Hence, the vacuum is like an unplayed piano. Each time you press a key, apply, that is the A dagger, you create a new note. That is nothing but a particle. So each mode K is a harmonic oscillator. H is equal to summation K omega K n K plus half. This unifies the quantum harmonic oscillator concepts with field theory. So small shift in hydrogen levels caused by vacuum fluctuations may be the example for connecting this quantum harmonic oscillator concept. So if atoms hear the quantum whisper of the vacuum, the Klein quantum field is a foundation for many physical models: Higgs field, the quantum inflation field, photons and nanomagnons, quantum optics, etc. So whether in the early universe or inside a crystal lattice, all are just vibrating fields obeying the same laws. Here in Higgs field, scalar field responsible for mass, and in inflation field drives cosmic inflation, and in phonons, second quantization in condensed matter, and in quantum optics, photon fields follow same law. So all are just vibrating fields obeying the same laws. Let me summarize in just that. The fields may be the operator, and Klein Gordon is the simplest relative scalar field. A dagger and A are creation and annihilation operators, and particle numbers changes naturally and matching the experimental reality. And these provides a foundation for QED, QCD, and the standard models. So every photon, electron, or Higgs you're ever heard of is just an excited field mode. Let me ask you a question. If the vacuum teems with energy and fields, can nothingness truly exist? Okay. Now connecting field quantization with cosmology, vacuum energy, and idea that matter equal to energy equal to field excitation. So we are made not of particles, but of standing waves in the fields that fill the universe. Thank you for listening. Thank you.